Hello everyone, welcome back to my channel. This is Jazz. So today we're here with another tree problem. That's right, we're looking at another tree problem today. If you're following my channel, you'll see that I've been doing a bunch of tree related questions recently. And I do believe practicing on the same category of questions or on the same data structure of questions is a very helpful way to build up your knowledge base for this data structure. And if you've been following along all the tree related questions, I'm sure today's question should look very familiar to you, and you probably already have an idea just by looking at the question itself. If you haven't really practiced those tree related questions, that's alright, I got you. I've made several videos on those tree related questions ranging from the very basic ones to some harder problems. And feel free to click on those videos and practice on your own. I'll link those videos in the description box. And without further ado, let's get started on today's question. So let's first read the question statement. You're given the root of a binary tree. Imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. Pretty straightforward question statement. We want to get the right side view of a binary tree. So what is a right side view? So think about a tree level by level. If you're looking from the right side, what you'll see is basically the last element of each level. So that doesn't sound too bad to implement, right? If you watched my video on the level order traversal, this should come really intuitive to you. And if you haven't heard of that question, or if you're not so familiar with the solution to the level order traversal, feel free to click on that video. I'll link the video on the top right corner. But if you are familiar with that question, I would like you to pause the video and think about the approach and then how you might use that approach for this current question, the right side view question. So quick recap on the level order traversal. The implementation of that question would be we're using two different queues. One queue called the current level and the other queue is called the next level. From the beginning, you're going to insert your root node to the current level, and then you're going to loop through all the nodes in your current level queue. And every time when you pop one node out from the current level queue, you're going to get its children and then push its children into the next level queue. And once you're done with all the nodes in your current level queue, you're going to replace your current level with the next level, so that your next level will become empty and your current level will contain all the nodes from your next level. So basically you're moving to the next level. And then you basically just repeat the loop until you're done with all the nodes in the tree. So from that implementation, what we can get is what nodes are in one level. So if you already have the nodes in one level, then getting the last element or the element that's on the far right should be fairly simple. And in fact, that is exactly what we're gonna do for this question. Alright, so let's dive right in. First thing first, we need to check if the given input is valid. So if not root, we just simply return an empty list. Then we'll be creating our current level. And initially, we're gonna put the root node into our current level. And then we're gonna make our next level, and it's gonna be an empty list at the very beginning. And then we're gonna have this result list that holds all the node values that is going to be returned. So now we write our while loop. While current level is not empty, then first thing we need to pop out the node on that level. So current level dot pop 0. And then we need to check if this node has a left child. If it does, then we add it to our next level queue. So node dot left. Same thing for its right child. next level dot append node dot right. So once we've added its children to the next level, what we need to do is to check whether or not this is the last element in this current level. So if not current level, meaning current level is empty and we've popped out all the elements in the current level, the node will hold the last element in the current level. Then we're going to add it to our result list. So node dot fill. And then we're going to replace our current level with our next level, meaning that we're moving on to the next level. And then we're going to set the next level back to an empty list. So once the while loop is done, once every node in the tree has been traversed, we just simply return the result list. Alright, so now let's take a look at the runtime and the space complexity. For runtime, since we're going through every single node in the tree in the while loop, so the runtime is just going to be big O of n being the number of nodes in the tree. Let's talk about what space complexity is for this implementation. So the maximum number that's going to be in this current level or the next level is going to be the maximum number of nodes in one level. And we know that if the tree is a complete binary tree, the maximum number of nodes in one level is going to be n over 2. So that being said, the space complexity for this implementation is going to be big O of n over 2. Or to simplify it, you could say it's big O of d, d being the diameter of the tree. Alright, so that's it for today, and I hope you enjoyed this video. Feel free to leave any comments or questions in the comment section, and feel free to check out the other videos that I made on tree traversals and to practice them on your own. Thank you for watching, and I will see you in my next video. Bye!